Hello, Patrick here with another Godot tutorial. This one on reflecting projectiles. I'm just going to try to do a pretty short and quick tutorial if possible. I know I usually run pretty long on my tutorials. And I will put some timestamps down in the bottom in case this does go a little bit longer. And also look for a download link for the project that I'm using here in this tutorial, so you can play with it and utilize aspects of it in your projects if you want. Now, rather than doing this from scratch, I'm just going to go ahead and show you what I've worked up ahead of time. Just a basic Node 2D for the world. I have a separate player and a separate cannonball node that I've instanced in, I've instanced the player in here. I just did a few static 2Ds as the floor and the two walls, with a sprite and a collision shape 2D on each one. I created a node 2D that I'm calling the turret, and that's this guy here. I just used the Godot icon and just changed its visibility, modulate all the way down to black to create these couple shapes here. Same thing for the walls and the floor. The turret has another node 2D that's the actual cannon part of the turret, and there's a position 2D attached to the end of the cannon, just as my spawn point for the projectiles that I'll be shooting, and a ray 2D that will make the turret fire when it sees the player. We'll go ahead and turn its visibility off for now. I have a reload timer on here. All that basically does is make it so that when the cannon sees the player and fires, it won't just fire a ton of bullets, it'll fire only one, and then set a boolean to false that will make it so the turret can't fire until it's set back to true. And that's the timer's job, is to set the boolean back to true after the right amount of time. And then I have a few tweens that I'm using just to control the movement of the turret. It's going to sort of slide across the top of the ceiling back and forth while the cannon itself rotates. The cannonball that is going to be fired by it is actually just an area 2D. I didn't bother doing any kind of physics body for it. If you like, I could do another tutorial showcasing how to do this with different types of physics bodies, if your bullet is a kinematic body 2D or a rigid body 2D. But for now, I'm just doing this node 2D for just to get a real basic method for making this happen. And the player is a kinematic body 2D. There's his collision shape. He has an area 2D. I'm using that in place of utilizing is-on-floor methods in his script, since the floor is not a tile set but a static body 2D. So I'm just using the player's area 2D to know when it's touched the floor. That helps with my jump mechanics. And then it has a separate, my player has a separate area 2D attached to him that is going to be the shield. And when you press the button to use the shield, it will switch its visibility back on and move the shield to the right or to the left, depending on which direction the character will be facing. I'm not using any sprites for the player or for the cannonball. I'm just using collision shapes, and in the debug options I have visible collision shapes, so that way when you're running this in the editor you'll see the collision shapes. Now let's take a look at some scripts here. We'll look at the player script first. Let's go to distraction free mode here. Pretty basic stuff. Motion set to vector 2, 0. We have a walk speed and a jump force, these export variables, so we can play with them in the editor. I'm using a physics process function, and I do the get action strength right minus left for the left and right inputs, and then I store that as a variable. So and then if I say if that variable equals 0, then we will go ahead and set our motion to walk speed times that x input times delta, just to make sure it runs at the same pace on different devices. And then if nothing is being pressed down, which means that x input would equal 0, then we're going to put motion.x to 0. In other tutorials, I've shown how to do linear interpretations to make smoother movement, but I'm just kind of slapping this together quick and sloppy, so no need for that right now. And then of course motion.y plus equals gravity times delta, and that's, I believe, a variable we have up here. We have a direction variable and this boolean so that we can not double jump in the air. Let's see, so if I push the up button and this boolean is true, then I'll be able to jump, and so when I jump, we'll set it to false, and then we'll apply the jump force to our motion.y. And when the area 2D detects hitting a body with the name floor on it, it will set jumpable back to true, so that way we'll be able to jump again once we hit the ground. And then I have the down button as the shield button, so when you press that, we'll go ahead and turn its collision shape, its visibility, back to true, and we'll move its position out 40 pixels to the right or to the left, depending on what direction is. And as far as direction, in the physics process up here in the beginning, I basically say if left was just pressed, we'll set that direction variable to -1, and then right to +1. And so that will plug that in and change which direction the shield gets held out. And then obviously when the down button is released, we'll put the shield back in the middle and turn its visibility back off. And then I do have, let's see here, let me just take a look. Yeah, I have also for that same area 2D that detects collisions with the floor, we will use that also as sort of the hitbox. So if the cannonball hits the player, we'll change the player's color with this collision shape. I'm just changing the color of the collision shape since there's no sprite. We'll modulate it to a slightly different color. Because I'm being lazy, I just did a yield. I don't normally like to do yields here. Normally I do timers instead, but for now we'll just do this yield get tree create timer at 0.5 seconds, and when it times out, then we'll set the collision shape's color back to its default. So that gives sort of the impression of getting hit. So that's pretty much it for the script of the player. Now let's take a look at the cannonball script. Again, it's just an area 2D, nothing special, but we do give a variable for speed that we're going to apply, and normally I would call this motion, but I called it movement direction just because of a method I was following from another Godot tutorial that helped me to understand how to determine projectiles' trajectory based on the raycast 2D and the point at which the raycast detects something that it's going to shoot at. But anyways, we set it to a vector 2.0 in a function process. I'm sorry, in a process function. We're going to set the position of this cannonball. We're going to actually take the movement direction normalized and multiply that times speed and delta, and that's going to constantly add to the position in that direction. And you'll see, I'll show you in a minute how the script for the turret will basically be plugging in things that will make that happen here in this when I'm setting my movement direction equal to point direction. This is a function that I created, and I created this variable called point direction, and we're saying that it's going to be a vector 2. We're just leaving it as a blank vector 2 right now. And then for the area 2D itself, the function for things entering it, we set different lines for if it touches the floor, if it touches each wall, it will just go ahead and queue free itself. However, if it touches the player before it queue frees, it will push the player back. The player being the body that it's colliding with, body.position plus equals that body's original position minus the position of the area 2D. So it's just a kind of a cheap but quick and easy way to get a little bit of a knockback. Normally I don't like to do that. I like to apply some sort of force to it or motion to it and not just alter the position, because sometimes that could result in problematic behaviors like getting pushed through walls, which we don't want necessarily to do that. And also the body, the player has a getting hit function, as I showed you earlier. So when the cannonball area 2D hits or when a player collides with the body here, I'm sorry, when a player body collides with this cannonball area 2D, this part of the script will tell that body to launch its getting hit function. And then we have another signal connected here for when the cannon, which is an area 2D, collides with the player's area 2D named shield. And when that happens, this is basically kind of the answer to your question if you had requested this tutorial about reflecting. We basically take whatever the cannon's movement direction .x is in this case, and we just make it equal to the negative equivalent of that speed. But I do need to explain this just a little bit further. So before we do that, let me just jump over here real quick to the turret. And I did not create the turret separate outside of the world node. I just created it within it. But it does have its own script, so we'll take a quick look at that. So we have the cannonball speed that we're going to apply. I don't know if I need that, but, well, hold on a second. Well, yeah, let me take a look here. We'll come back to this here in just a moment. So we have that reload boolean I told you about earlier, just for controlling the timing of the cannon's fire, right? We need to do a preload of this cannonball scene that we created so that we can then reference that and instance it into the world here. I have created a function called turret rotation, which I have the ready function launch as soon as the game starts, and that's just applying tweens to change the rotation of the turret, of the cannon part of the turret, and to change the position, making it move back and forth. And then of course we got to do start on each of these, otherwise they won't launch. And then each of these tweens, the regular tween and tween 3 and tween 4, have signals attached to them. See here, signal on all completed. So when the tween is completed, then we'll set up tween 2 to now change the rotation degrees back and start it. And then when tween 2 completes, it'll have its signal, which then connects here, which then tells tween 1 to start again. So we can now get these two kind of going back and forth in a loop with each other. Same thing with 3 and 4 for the sliding back and forth movement. And then the timer, when it times out, well, when the cannon fires, I should say, it will start the timer, the reload timer, and then when that reload timer times out, it will turn the reload back to false, because the firing of the cannon will have turned reload to true. So just a quick look at this. If the ray 2D, which I just renamed it ray, is colliding and reload equals false, and we further check if that collider that is colliding with has the name player, only then will it launch the rest of this code here. It'll say that it'll turn reload to true, so it can't fire again until it's false. It'll start that timer. We're going to create within this function just a smaller variable that I called CB, and we're going to set that equal to cannonball.instance. If I didn't do this, I could still instance the cannonball without creating this variable. It's just every time you try to reference the cannonball, you're going to have to call it cannonball.instance. That's a lot of typing. So we just create this little variable to make life a little easier. Then we say get tree, get root, that root being the the root of this scene here, and we're going to go ahead and add child. It's not enough to just instance the cannonball. You have to then add it as an add child, and we put the variable name CB inside these parentheses here. And then I also create a player variable, not to be confused with the actual player itself. This is just a variable that represents the collision point that the ray 2D has made when it touches the player. And then again, that just makes things easier, so I don't have to keep typing out no 2d/ray.getCollider every time I want to reference player. And so then, of course, we need to set the position of the cannonball when it spawned, and we're going to set it to the global position of the turret. I could also have said, I probably should have actually done this. I could have said node 2D position 2D. So that would be the position. Oh, and I have to say dot global position, so that it'll spawn the cannonball from the node, the position 2D that we have there. I just forgot to do that. And then now let's see here. Setup. I think this is, yeah, okay. So cannonball, we have a function here. That little function right here, just called setup, that I created, and I created that variable called point direction. So basically, in the turret script, once we have instanced and added the child cannonball to the scene here, we're going to tell that cannonball, we're going to tell it to launch its setup function. And inside of the parentheses here, we're going to go ahead and add the node, oh, you know what? No, that'll work. The collision point, so the place at which the ray 2D had made contact with the player, that location minus the position of the turret itself. So minus the origin of the cannonball, I should say. So that value now gets plugged into the cannonball script, gets plugged in, and so this vector 2 now will have that value of the collision, the collider point, the collision point of the ray 2D and the position of the cannonball. Hope that's not too confusing. I'm trying to explain it as best as I can to make it understandable. So once that happens, then movement direction gets set to that value that we established over here in the turret script, which basically just tells it, a trajectory. If we're at a weird angle, then it'll know to travel in that line towards the point where it saw the player. Okay, I think that pretty much explains everything that I have set up here. Now, let's just go ahead and run the game real quick to show you how that all works, and then how the reflecting of the projectile works. Okay, oop, I just got hit. So there's the cannon shooting its projectiles. Here's the player. When I get hit, it kind of knocks me in a direction a little bit, and it's not perfect. It's a little chintzy, but it works. And if I hold shield down, there's the shield. Dink. See, there it goes. It just bounced right off of the shield. And as you notice, as it hits, it continues its motion.y, or whatever you want to call that. It continues its y motion down, but because in my script I had just said whenever the cannonball interacts with a shield, we're just going to reverse its x-axis of direction. Now, if you wanted to reflect the projectile directly back at the cannon, then you would just take off the .x. It's really that simple. At least if you're wanting these basic kinds of motions that are maybe not perfect for physics, but they work pretty well just for kind of bouncing it back at the source. Well, that's all we're doing. We're just reversing its trajectory, its direction that it's traveling in. Now, I will note that this will probably work a lot differently if you used a rigid body 2D, because you could just, if you're just trying to have the ball or the cannonball just bounce off as it would just naturally at whatever angle that you're traveling, that the ball's traveling, then you can just rely on the basic built-in physics of a rigid body 2D, and the bounce off would be pretty basic. As far as directing it back to the source, I haven't played with that yet with the rigid body 2D. I suppose it would be pretty simple, but maybe not as easy as it is here, just doing it with an area 2D without any kind of physics body there. Now, if you did this with a kinematic body 2D as the projectile, then I think you would need to use the bounce method, which I can do in another tutorial if you like. It's a little trickier, at least for me, because I haven't worked with it very much yet, and I've had some issues trying to get the physics to look good with kinematic body 2D bounces or ricochets or what have you. So anyway, that's what I have for you. Hopefully this is helpful to somebody out there, and if anybody has any suggestions of some better ways to do this, I am always open to new knowledge, so please drop it in the comments below. And if you have any questions for me, drop those as well. And don't forget to download the project here if you would like this. And give me your input, and I'd love to hear from you. Thanks again, and happy coding.